This is the self-assessment for sections 21, 22, 26, 27. How you go about solving systems of equations really depends on you. Do you want to use graphing, substitution, elimination, or do you want to use a matrix? This particular problem I will solve using substitution just because I want to practice them all. This one's actually set up to do substitution. You would take the negative x minus 2 and substitute it in for y. So you would write 2 parentheses negative x minus 2 equals negative 4x, thus creating an equation with one variable, x. So you would distribute and get negative 2x minus 4 is equal to negative 4x. And then you would get your x's on one side and your constants on the other. And it doesn't matter how you do that. I would just do this. I would add 2x to both sides, and I would be left with negative 4 is equal to negative 2x. And then I divide by negative 2, and I find out that x is positive 2. Now that I know what x is, I can find out what y is by substituting in 2 for x into either of those two equations. And it doesn't matter which one you pick, so I'll pick the bottom one to plug into. When you plug in 2, notice that I put it in parentheses, and that minus sign is on the outside of the parentheses. It's going to make it negative 2, and negative 2 minus 2 is negative 4. So the ordered pair of the point of intersection is 2, negative 4. Now you could have also solved the first equation for y and then graphed them and found the intersection. You could have set both of these up to do a matrix. If you'd wanted to use a matrix to solve it, I would have made the first equation 4x plus 2y equals 0. And the second equation would be x plus y equals negative 2. And then you would have plugged it into the matrix function. You would plug 4, 2, 0, 1, 1, negative 2. It would have been a 2 by 3 matrix, and you would have used that RREF function, and you still would have found out it was 2, negative 4. How about we do one where we graph it and find the point of intersection? In order to graph it and find the point of intersection, you need to have both equations in slope-intercept form. The first equation's in slope-intercept form, but the second one isn't. So I'm going to solve the equation for y. So I would, oops, I shouldn't subdue that. It's positive x. I'm going to add the x, and then I'm going to divide by 6. And then I'm going to graph both of these in y equals on my calculator. So then you would see this. And you know the point of intersection is right there. To find it, you hit second and then the trace button. Number 5 is intersect, and then you hit enter 3 times. Not enter times 3. You hit enter, enter, enter until you see the word intersection at the bottom of the screen, and it should tell you that the intersection is at 6, 1, which makes sense because it kind of looks like it's at around 6, 1. What if you wanted to use elimination to solve one of the systems? Well, for this particular problem, in order to use elimination, we want both the equations to be in standard form. The first equation is in standard form, but the second one, I just have to flip-flop the x and the 3y. All right, in order to add these together, one of the variables needs to disappear, and right now when I add them, none of the variables cancel. To get one of the variables to cancel, how about I multiply the second equation by negative 2? The reason I'm going to do that is because now I'm going to get negative 2x minus 6y is equal to 2. Look what happens when I add the first equation that I didn't do anything to and the second equation. I get negative 11y is equal to 2, so y is equal to negative 2 over 11. I know you probably don't like fractions, but that's okay. We can still do this problem. All right, so now I'm going to plug back into one of the 2 original equations to find x. How about I plug into the second one? So 3y plus x equals negative 1. 3 times negative 2 over 11 is negative 6 over 11. And then I'm going to add 6 over 11 to both sides. Well, luckily, I can just do this on my graphing calculator. If you do -1 plus 6 over 11, and then you hit math, enter, enter, when you get your decimal, you should get x is equal to -5 over 11. So the point of intersection is -5 over 11, -2 over 11. Well, what if I want to use a matrix? All right. In order to use a matrix, I need both the equations to be in standard form. Standard form means that both x and y are going to be on the left-hand side of the equal sign. So I subtract the 6x to put it on the left. The second equation, I just have to rewrite it. It's a -15x, but a positive 2y. Now, I can make my matrix. The first row is going to be -6, 1, 1, and my second row is going to be -15, 2, -4. Remember, we plug that into second x to the -1st, that's the matrix function. You go over to edit, and we're going to just put this in number 1, matrix A. It's a 2 by 3 matrix, so you have to hit 2, enter, 3, enter to make sure it says 2 by 3. And if it already says 2 by 3, then just go into the matrix and start changing the numbers. Every time you type in a number, you need to hit enter to lock it in, otherwise it won't. Once you've typed your numbers in, you quit second mode, and then you go back into matrix a second time, but this time you only arrow 1 to the right to math, and you scroll until you find option B, RREF, and hit enter. So that RREF shows up on your home screen. Then you go back into matrix a third time, but this time you just hit enter twice. And unless the problem has no solution or infinite solutions, the last column should be your solution. In this case, the last column should be 2, 13. Again, this is a problem where I would just plug it into a matrix because it's already set up to do that. However, you can choose whatever method you want. I like using a matrix because then I don't have to worry about multiplying each equation by something in order to add the equations and cancel something. Again, it's a 2 by 3 matrix. You use the steps from the previous problem. You should get the solution of 1, 2. Definitely, if a problem has decimals in it, I would use a matrix. But you need to be careful before you decide you're going to use a matrix. I want you to notice that the second equation is not in the right order. It needs to be in X, Y order. And if it's not, you need to change it. So you would need to change the second equation to be -x plus 3y equals 13.5 before you plug it into the matrix. Or if you want to go do elimination, well, notice those cancel. You're left with 8y is equal to 34. So y is going to equal 4.25. And then once you find out y is 4.25, you plug it back into either equation. I'll plug it into the first one. Five times 4.25 is 21.25. And then when you subtract 21.25, you get -0.75. So the solution is -0.75, comma 4.25, which you would also have gotten had you done a matrix. If you want, you can also change these decimals back into fractions by hitting math, enter, enter, and this is -3/4, and this is 17/4. The systems that are in 3 equations, 3 unknowns, you'll need to use a matrix to solve. The only thing I want you to watch out for before you shove it in your calculator is it in order? Is it X, Y, Z equals constant? Are there any missing terms? If there's an X or a Y or a Z missing, you'll want to put a 0 in its place. The matrix that you should plug into your calculator is 1, -2, -3, 2, -3, 5, 4, 0, 1, -4, 3, 14, and you should get the answer of -10, -6, 0. In problem number 8, the matrix you should use is -1, 2, -6, 4, 1, 1, 2, 3, 2, 3, -4, 5, and the solution you should get is -1, 3, 1/2, or 0.5. In number 9, the matrix you should use is 1, -2, 1, 7, 3, 1, -1, 2, 2, 3, 2, 7, and the solution you should get is 2, -1, 3. In problem number 10, we want to graph these 3 inequalities, and then we want to find the vertices of the shaded region, and then we want to plug those vertices into a function to find which one gives a minimum and which one gives a maximum. So I'm going to graph them all by hand. I'm going to use different colors here. The first one, y is greater than or equal to -3. Remember, if y is the only variable, it's going to be a horizontal line, and it's a horizontal line through 3, and the shading for that one is going to be above the line. X is greater than or equal to -2. That's going to be a vertical line because X is the only variable. It's a vertical line here at -2. And its shading is going to be to the right. So we already get a sense that the shading is going to overlap somewhere in there. The third one, the y-intercept is 7, and the slope is -5/2. So I'm going to go down 5 to the right 2. 1, 2, 3, 4, 5, 1, 2, put a dot. I go 1, 2, 3, 4, 5, 1, 2. And I'm going to end up going off my graph to find the rest of the complex, convex, polygonal complex set, whatever it's called, because I know that this isn't going to close yet. I need to go 1, 2, 3, 4, 5 up and 2 to the right, wherever that is. So 5 up, I was at 7 here at this top dot. Let's see, 8, 9, 10, 11, 12. So this point I know is going to be at -2, 12, even though it's kind of off my graph. And then I'm going to draw that line. Try to make it a little bit straighter. It's not going to come very straight here now, is it? There we go. And that one gets shaded below the line. That's what less than or equal to means, which means that my shaded region is going to be in this triangle here. So now the vertices, which we need to find in part B, one of them was there at -2, 12. This one here is at -2, -3. And then over here is at 4, -3. And then in part C, we're going to take those 3 ordered pairs and we're going to plug them into a function. And the function we're going to plug them into is f of xy equals 2x minus 5y. So when I plug in -2, 12, I'm going to get 2 times -2 minus 5 times 12, which is -4 minus 60, which is -64. Now I'm going to plug in -2, -3. 2 times -2 minus 5 times -3, which is going to be -4 plus 15, which is 11. And then the last one, 4, -3, 2 times 4 minus 5 times -3 is going to be 8 plus 15, which is 23. Well, clearly, This is my maximum value of 23. It occurs at 4, -3. And this one is my minimum of -64, which occurs at -212. Problem number 11 is a linear programming problem. It says Ingrid is planning to start a business. She will be baking decorated cakes and specialty cakes, or specialty pies. She estimates that a decorated cake will take 75 minutes to prepare, and a specialty pie will take 30 minutes to prepare. She plans to work no more than 40 hours per week and does not want to bake more than 60 pies in any one week. If she plans to charge $34 for a cake and $16 for a pie, find a combination of cakes and pies that will maximize her income for the week. Well, first we need to define our variables. Let's call X the number of cakes, just because cakes came first. And we'll identify Y as the number of pies. All right, so now we got to go back and write some inequalities to represent the amount of time spent baking cakes and pies. Well, she's going to spend 75 minutes for the cakes and 30 minutes for the pies, but she can't use more than 30 or 40 hours. Wait a second, hours and minutes don't quite go together. And since these are both minutes, we're going to have to convert 40 hours to minutes. 40 times 60 is 2,400. And now that it's all in minutes, we have an inequality that will work for us. In part B, it says, write an inequality to represent the restriction on the number of pies Ingrid will be making. It says that she does not want to make more than 60 pies in 1 week. So Y needs to be less than or equal to 60. Then in part C, it says to graph it. In order to graph it, I want to first go find the X and Y intercepts of the first inequality. That way we can determine how we're going to scale our graph. So the X-intercept, 2,400 divided by 75 is 32. And the Y-intercept, 2,400 divided by 30 is 80. All right, now that I brought my graph up, let's go talk about how we're going to scale this. So the first inequality, I need the X-intercept to be at 32, the Y-intercept to be at 80. For the second inequality, Y is less than or equal to 60. I just need to be at 60. So why don't I make the scaling on here to be every 10? So the first inequality, the X-intercept is 32, so 10, 20, 30, 40. So 32 is here. And then the Y-intercept is 80, 10, 20, 30, 40, 50, 60, 70, 80. That looks terrible. Let's just get rid of that and start over. All right. There's my first line, and I'm going to shade below it. My second line, because it has Y only, is going to be horizontal. And it's going to be a horizontal line at 60, which is going to be right here. And it's also getting shaded underneath, so my shaded region is here. So after I graph it and I find my shaded region, the next thing I'm going to do is I'm going to find the vertices. Well, I've got 0, 0. This one here is at 32, 0. This one here is at 0, 60. But these two lines intersect here. How do I figure out where that is? Well, since the green line is Y is 60, why don't I plug 60 into the other inequality for Y to find out what X is? So it's 75X plus 30 times 60 equals 2,400. So 75X plus 1,800 is equal to 2,400. I subtract 1,800, and I get 75X is equal to 600. And then 600 divided by 75 is going to be 8. So it turns out the last ordered pair is at 8, 60. Then in part E, we need to write the profit function so that I can plug in these vertices into that profit equation in order to determine my maximum. So at the very beginning it said she plans to charge $35 for a cake and $16 for a pie. So my profit function, P of xy, is going to be 34x plus 16y. Well, now let's plug those numbers in order to find our maximum. So clearly, if I don't make any cakes or pies, I bet I'm going to make $0. But how about if I make 32 cakes but no pies? I'll make $1,088. All right, how about if I make no cakes but I make 60 pies? I'll make $960. How about if I make 8 cakes and 60 pies? I'll make $1,232. So guess what my maximum income for the week will be? It'll be $1,232 if I make 8 cakes and 60 pies. And that was the review for the 21222627 test.